Alright, so we're going to be moving on to sections 4 and 5 in pre-calculus. This is kind of a doubled up section because of um, just the topics themselves. They kind of go together, so we're just going to smash them together. So, here we go. Oh, so do the following look pretty? Does this look pretty? How about this? How about this? How about this? And this? And these? And this one? Do these all look pretty? And you could say, yeah, they all look pretty. They all look nice. Yeah, tiger. But yes, you could say they all look pretty. And you'd want to go, well, why do they all look pretty? And the reason why they all kind of look pretty is because they are all symmetrical. They all have reflections. So, let's talk about symmetry and reflections. And then we'll get into transformations a little bit later. But let's start off with this. So, reflections. So there are three different types of reflections we can have with our functions. First off, we have our reflections along the x-axis. Now, when you reflect something along the x-axis, what that means is that the y value is the opposite. The x value is the same, but the y value is different. So if you have a point up here, let's say, we have this point, negative 4, 4. If you want to reflect it around the x-axis, which is right here, this line, the horizontal one, that means that you have to move it all the way down here to negative 4. But the x value doesn't change, the y does. So that's why when you reflect it around the x-axis, the y changes. It's the opposite. So you see here with this parabola that's kind of fallen on its side, you would see that it is reflected around the y-axis. Or the x-axis, my bad. X-axis, not y. Okay. Next up is a reflection around the y-axis. So if it's a reflection around the y-axis, which we have a parabola here, that means that the x value is changing. So if you know if the y value, let's say here is 2, okay, the x value is negative 2, and the x value is positive 2. Down here, when the when the y is 0, your x value is like 1 1/3, positive and negative. Okay, so that's when we have a reflection around the y-axis. Okay, so it's the same on either side of that y. Last one is a reflection around the origin. Okay, so if it's a reflection around the origin, that means that the x and y are both positive and negative. So if we look over here at this point, we can say, let's say this point is positive 1, positive 2, or positive 2, positive 2. Let's just make it simple. Positive 2, positive 2, that means that we also have negative 2, negative 2 as one of our points. If we have negative 2, positive 2, we also have positive 2, negative 2. Okay, so you see the signs, both signs change, the x and the y. That's a reflection around the origin, which is right there in the middle. Now, why is this important? Okay, so we're going to be using these and we're going to be testing them algebraically. So visually from a graph, if you look at the previous 3, you can see that, yes, okay, that's a reflection on the x-axis, I can see it. That's a reflection on the y-axis, I can see it. That's a reflection on the origin because I think it is. It is. Okay. So it is something that you could visually see. But now we have to talk about what if we do it algebraically instead of graphically. So what we would do here is that if we want to do it around the x-axis, what we have to do is we have to replace the y with a negative y. And if you replace the y with a negative y and you get the exact same answer, then that means that yes, it is a reflection around the y-axis. Basically, if you plug that number in and then you simplify the equation and it goes back to the original equation, it's a reflection around the x-axis. If you replace the x with a negative x, then it's a reflection around the y. If you change them both, then it's a reflection around the origin. Okay. And again, if it comes up, it's the same number. So let's do an example. So we're looking at this first one. So we have f of x is equal to x squared plus 5. So when you reflect it around the x-axis, you change the y value. So the y is now a negative y. Now, if I were to go through and solve this and get y by itself again, do I get the exact same answer? And that answer is no. When you multiply it through, you end up with a negative x squared minus 5, which is not the same. So that means that this function is not a reflection around the x-axis. Next step, we replace the x with a negative x. So now if we simplify this, y is equal to negative x, that whole thing squared plus 5. If we simplify it, Negative x squared is simplified down to x squared. And so that's reflected, or that's simplified down to x squared. That is back to the original, which means yes, it is a reflection around the y-axis. So now we do the same thing and we change the x and the y. We change them both negative. When we simplify it, we end up with a y is equal to negative x squared minus 5. Is that the same as the original? That answer is no. So because it's no, that means that it's not a reflection around the origin. This is fairly simple to see because if you were to graph it, it is a parabola opening up at 5 as its y-intercept. And as you see from there, it's not a reflection on the x-axis. It's not a reflection on the origin. You can use your calculator with this to help you to identify. If you're unable to visually see where the graph is, then that's where your algebraic can come into play. Okay, so take a second. Here's the original problem. X squared plus y to the fourth is equal to 5. I want you to identify if it's a reflection around the x-axis, the y-axis, or the origin. Now, when you've gone through and simplified each one of these, when you simplify the first one, negative y to the fourth power ends up getting us back to the original. So, does that mean it's a reflection on the x-axis? Sure it is. So it's a reflection around the x-axis. Next up, we do it with the y. X squared, or negative x squared gets us back to an x, which means, yes, it is the same. So that means sure is a reflection around the y-axis. Okay? And then we do the same with the last one. We do it with the origin. Negative x squared plus negative y to the fourth is equal to 5. Simplify it, and you can put it on the board. Yes, it is. Okay? So, it's a reflection around all of those. This is basically kind of like an ellipse shape, I believe, if I'm visualizing it right, centered at the origin. So it looks something like, I don't know, probably something like that. And so it's a reflection on all of them. So as you see, you can have a reflection of multiple. It doesn't have to just be one. Now, if a function is symmetrical with respect to the y-axis, that means it's considered an even function. So if you are reflected around the y-axis, you consider that function to be even, which is, again, if you change the x to a negative x and you get the exact same function. Reflection around the y-axis is an even function. Y equals x squared, even function. If it's a reflection, or if it's symmetrical with respect to the origin, then it's considered odd. So that's where you change the x and the y, and you end up getting the same. A circle, x squared plus y squared is equal to 5, would be considered an origin, or a odd function. Now, can it be both? It can. It can be both. And could it be neither? Yes. Okay, so a vertical transition, or translation. A vertical translation is when you have a graph and you shift it vertically up and down. So you shift it either up or you shift it down. Okay, and that is when the b value is, assuming the b value is positive. And so if a graph such as y equals f of x. So this is assuming that you have like an original function, and then you're manipulating it. So if you have a normal function, and then your manipulation is that at the end of it, you add a number to it. You add 3 to it. What happens is you take that entire graph and you've shifted it up 3 units, or in this case, b units. If you take that original function and you subtract it by a number, that means you're shifting it down that many units. Okay, so the whole graph gets moved down. Okay, so that's your vertical translation. Okay, a horizontal translation is if you are going to shift it left or right. Okay, so left-right is your horizontal translation. So this is again assuming that d is positive. And with this one, the graph of y equals f of x minus d on the inside of the parenthesis. If it's x minus d, that means you're shifting it to the right, okay, d units. If it's x plus d, that means you're shifting it to the left, d units. So an example of this is that if we have our original one, y equals x squared. So if that's our original function, then what we're going to do is that we're going to take y is equal to, and we're going to go x minus 2, that whole thing squared. That function would be shifted to the right 2 units, okay? So the subtraction moves it to the right, the addition moves it to the left. Okay, so that's how these are manipulated horizontally. Okay, so vertical stretch and shrinking. So for a given function y equals f of x, okay, you're stretching it when you're multiplying it by a times your function, but the absolute value of a is greater than 1. Okay, and what we mean by stretching it is that you're taking the top and bottom of it. So if this is our normal parabola, you're grabbing it from here and here, and you're pulling it in opposite directions. And then what's going to end up happening is that you make it narrower. Okay, you stretch it out. Okay, from the top and bottom. If the a value is between 0 and 1, the absolute value of it, what ends up happening is that you end up shrinking it. So if the original parabola looks like this, what ends up happening is that you're taking these two and you're kind of squeezing it. Okay, you're pushing it in, and then you end up with something that is flatter. Okay, that's what happens. So if you have a number greater than 1, the absolute value of that number greater than 1, you're going to shrink it, it becomes narrower, or stretch it, it becomes narrower. If it's between 0 and 1, it's going to shrink, and you're going to be smashing it down, and it's going to make it flatter. Okay. Horizontal stretch and shrink. So same thing, but this time you're adjusting it horizontally, and as you see here, you're affecting it within the x value. So you're multiplying x by something, not adding or subtracting. And so your horizontal shrinking is if the c value is between 0 and, or is greater than 1. Okay, and so this one, if our original function looks like this, the shrinking would be pushing it in like this, creating a narrower one. Okay, and the second one, if it's between 0 and 1, if we have our original, what we would end up doing is that we're stretching it, so we're pulling those edges outward, giving us more of a arc like that. Okay, so horizontal and vertical. Horizontal, if it's affecting just the x's, it's horizontal. If it's affecting the entire function, it's a vertical. Okay, all right, so that's the end of that section dealing with translations and symmetry. Okay, so that's the end of sections 4 and 5.